All right, now that we have an introduction to limits, we're going to go ahead and learn some new limit notation and how to apply it graphically. So, a reminder, a limit is what is the y value as x approaches blank. All right, so there are a couple different things that we can look at when evaluating limits, and that's our notation. So from our last lesson, we had a limit that looked like this. The limit as x approaches, I'll say in this case, 3, and my new function today is g of x. Okay? So this is saying the limit as x approaches 3 of the function g of x. What does that equal? Well, if I look at my graph, a limit is saying what y value am I approaching? So if I look at my graph, my y value, as I get closer and closer to 3, my y value is approaching 0. So the answer is 0, right? Straightforward. If you're looking at a graph, all you're looking at is the y value. But there are a couple notation things that we're going to look at. The first one is if we saw something like this. The limit as x approaches 3, and there's a plus sign on there. The limit as x approaches 3 with this plus sign of g of x. This is what we call a right-sided limit. What that means is we are just looking at the y value from the right side. So, as I approach 3 from the right, so I'm coming in from the right side, and as I get closer and closer to 3, that graph is approaching 0. And right now you might be thinking, well, yeah, we already know the limit is 0, so the right-handed is 0. But there's a reason we're talking about this, so we'll get there. So again, if it has a 3 plus, that means you're coming in from the right side only. On the same thought process here, if we have the limit as x approaches 3, and there's a minus sign. So the limit as x approaches 3 with a minus sign of g of x. That minus sign, that makes this a left-sided limit. So, as I come in from the left side, what is my graph approaching? So as I come in from the left, as I get closer and closer to 3, we're still approaching 0. All right. The reason we go through this, for one, is to understand this notation. 3 with a minus is left-sided. 3 with a plus is right-sided. And when you see just a 3 or a 7 or a negative 8, whatever that number is, this is a double-sided or a two-sided limit. That means we're coming in from the left and the right. Okay? I'm going to write a mathematical sentence on the board, and then I'm going to clarify what it means, but it's very important. Okay? So, the limit as x approaches c of g of x exists if and only if the limit as x approaches c from the right of g of x is equal to the limit as x approaches c from the left of g of x. The limit as x approaches c of g of x exists if and only if the limit as x approaches c from the right of g of x is equal to the limit as x approaches c from the left of g of x. So what that's saying is if my left side and my right side limit don't match up, they don't approach the same y value, then the double-sided limit does not exist. All right, let's take a look. So, what this is saying, if I want to know the limit as x approaches 0 from the right of g of x, 0 from the right. So if I come back to my graph, as I come in from the right side, as I approach x equaling 0, so as x equals 0, the graph is approaching 3. So the limit as x approaches 0 from the right of g of x is 3. All right? So now I want to know the limit as x approaches 0 from the left of g of x. So as I approach 0 from the left side, that graph is approaching 0. So my right-sided limit is 3. My left-sided limit is 0. So the limit as x approaches 0 of g of x, my left side and my right side do not match. So my double-sided, or my double-sided, both-side limit, the limit as x approaches 0 from both sides does not exist. And you'll see me shorten that to DNE, does not exist. So if the left side and the right side limit do not meet at the same point, so they look like this, whatever, then that limit does not exist. All right, so on your homework, you should now be prepared. I think it starts around 1921. Those values or those questions are approached using graphs, okay? So go on and evaluate those limits. If you have questions, shoot me an email. All right, I'm back. P.S. I forgot to talk about our equations here and how we can use those. All right, so really quick. If we were asked to evaluate this limit right here, the limit as x approaches 3 of g of x, the question might be a simple, does it exist or what is it? Well, if I don't have my graph to look at, but I have my equations, what we're going to look at is these two equations. The reason why is they meet at 3. So I've got to figure out if my two graphs have the same y value. So I could take the 3 and I could plug it in. Negative 3 plus 3, well, that gives me 0. All right. Then I do the same thing here. I'm going to take the 3, plug it in. 3 minus 3 is 0. 0 cubed is 0. Since the left side and the right side, those two graphs meet, the limit exists, and it's 0. Make sense? Okay, we see that here. Cha-ching! All right, and then to see this one. If we have the equations, we're going to do the same thing, but we're using two different graphs because these two meet at 0. So if I take 0 and I plug it in here, 0 squared is 0 times negative, well, that's 0. And then if I plug my 0 in here, negative 0 plus 3, well, that's 3. These do not match, so again, this limit does not exist. Thanks. Hope that helps. See you later.